All right, we might be live. I think we maybe didn't run our intro, which is. All right, now we're actually here. Hello, everybody. So this is Kubernetes by Example Insider, and we do a show where we try to talk to people who are deeply involved with the Kubernetes ecosystem as contributors, so that we can find out what's happening. Coming soon, because unlike a typical product, for example, we try to find. When we talk to product managers in a typical product, they have the idea what's going to happen. With the open source world, it's often better to actually talk to the engineers, because then we might have some clue of what might really happen. So that's what we're doing today. So I'm Langdon White, and I am a faculty member at Boston University now. I used to work for Red Hat. And joining me is my co-host today is Josh Burkus, and he will introduce himself.
Yep. Howdy, everybody. Josh Burkus, Red Hat's Kubernetes community manager, and SIG chair in Kubernetes and a few other things, and aficionado of things serverless, which is what we're going to be talking about today. So just to kick stuff off for our audience, do you want to explain what the difference is between serverless and microservices? And since we're going to be talking some about Java, for that matter, the old service-oriented architecture.
Yeah, I can do that a little bit. But before we get too much further, we should probably introduce our guests. Today we have Daniel O of Microservices fame, and sorry, I'm clearly far too early in the morning for the West Coast, and so we could introduce you.
Yeah, so Daniel O is a contributor to the Quarkus project, more than anything, but also Knative, which Quarkus uses, and Quarkus allows you to run Spring and other Java applications and possibly non-Java applications on Kubernetes.
Right. So Daniel, you're primarily responsible for kind of outreach to developers, right? With that group, and James, you're I know an old school Java guy, but what's your relationship to serverless these days?
Yeah. So. Thanks for having me. So James Falkner, I run product marketing and technical marketing for several of Red Hat's application development projects and products, many of which are not only compatible with, but as you mentioned, use and can have native integrations with serverless capabilities on Kubernetes, things like Knative and other ways of executing code across container orchestration platforms, cloud platforms, et cetera, et cetera. So I'm former, I'm a recovering developer. I worked at Sun Microsystems on Solaris for a number of years, and then moved into the Java space in around 2008 and joined Red Hat in 2016. So since then, I've been helping to evangelize the goodness of Java and capitalize on its popularity along with Red Hat's portfolio.
Did we go? Yeah, did we go over this? Were we at Sun at the same time?
It's very likely. I was there from 97 till 2010.
Oh, well, that would cover it. That would kind of cover it, wouldn't it? Yeah. Yeah, I was there from 06 to 08. So.
Okay. Yeah, it's a good time. I was at Sun for 13 years in Oracle for 6 months, and then I was actually community manager. You mentioned you're a community manager. Former community manager for a product called LifeRay, an open source Java portal, before coming to Red Hat.
With the portlet for Bible verses installed by default.
Yeah, that's right.
Yep,
that's right.
So I also want to apologize a little bit because I'm on the West Coast this week, and it is very early for me. It is about the same time as for Josh, but he's like used to it, and
I'm totally used to it.
I don't care for morning.
This is completely full of coffee.
I hear you. I have not had it anywhere near enough. So the reason we wanted to invite both of you today was to kind of talk about what you're seeing as kind of the future of microservices on kind of on the Kubernetes platform. Why is it interesting? What's kind of what's new and different about microservices versus our traditional service-oriented architectures?
We can talk a bit about that.
Sounds cool.
So, all right, then I will, if James didn't leap at the chance, I will ask Daniel to say, want to tell us a little bit about why microservices are interesting, why they're cool, and why you're interested in them.
Yeah, for sure. So yeah, just once again, that Daniel O. I'm actually working the James Falkner team, like a developer advocate and technical marketing, as well as CNCF ambassador. Yeah, so the microservice was born like 7 and 8 years ago, and then but for that we are all working with the monolithic application to run multiple modules to implement business application. But things changed there, so cloud platform came out, and then we're looking for the more optimized and then more portable and standardized application. For example, you want to run single application with a single independent business requirement. In order to that, the microservice architecture actually help us to make that happen, regardless of any application runtime like a Java, .NET, or Python, NodeJS, whatever you need. So main purpose of the microservice architecture, you're going to run independently the application runtime, but also you're going to serve the single business domain or capabilities. And then it really fit into your container orchestration platform like a Kubernetes. You're just packaging one containerized application with a single microservice application and then running on top of the Kubernetes or cloud, and then you have a huge high scalability and the flexibility and portability as well.
Yeah, one of the interesting things, Josh, you mentioned SOA, I think, earlier. I've commonly heard the phrase microservices is SOA done right, which is kind of funny because like the concepts and the way you develop microservices that Daniel mentioned, it's like, well, we had this 20 years ago with or maybe it probably was 20 years ago by now, for service-oriented architecture. The problem with SOA wasn't the concept of a service-oriented thing. It was the way that it was implemented and the centralization of the contracts between the different services into like this central integration team, and it kind of produced a big bottleneck and slowdowns in terms of making changes to or developing new and making changes to existing applications that need to talk to different services. So microservices, in addition to the architectural benefits, it's also if you split these services across business domains, and you also match that to your development teams, so that you can have these autonomous teams building these services and then independently publishing them, then the benefits of microservices start to really shine through. It's not like the application is getting simpler. Actually, microservices makes things more complex. But if you adopt the idea of these independent services being developed independently by, as we've all heard the phrase, two pizza teams, then that's where the real benefit comes. And that's really the big difference between the microservices of 2 decades ago, which we called SOA, versus what we're doing these days. And then serverless, as we'll probably discuss, improves upon that even further.
And just to clarify, what you mean is SOA or service-oriented.
Yes. Yeah, that's right. That's right.
Because I will not allow the term SOA to appear.
Okay. Service-oriented architectures.
Yeah.
That's right.
Yeah, conceptually, I mean, it's funny, right? Because we've actually been doing that. I mean, if you can kind of trace back, various implementations of how to do services for a long time. I mean, even if we look at things like Corba or whatever, clearly the concept of a service, whether it's you call it an architecture or whatever, but the concept of a service is really fundamental to building scalable applications. And what I think, at least for me, one of the big differences as well, you kind of mentioned, kind of services done right, except I also add in is also the approach. SOA was very much a top down. It's like this ivory tower of architects would come up with this perfect plan, and it would take them months, if not years, to develop that plan, right? And then they would feed it out in bits and pieces down to the development teams. What's so interesting about the microservice model, even though conceptually it's actually a very similar idea, you're actually kind of going bottom up. So you're only building things that people are actually using or actually need. And what we found, right, this was also similar to the transition of waterfall to agile, is that when you, if you kind of approach software development in terms of building only what you need when you need it, you end up with a much better end product, if that makes sense. So that's the other big thing, at least for me, why I think microservices,
absolutely.
can be more, even more exciting.
Yeah, one thing we have to be careful about is making everything microservices. Like there are cases where it doesn't make sense, depending on the size of the team and the culture of the organization that is building the application. Monolith might be perfectly fine. I think, was it I can't remember his name, but the founder of Basecamp actually just made a conscious decision not to do microservices because of the nature of their team and the fact that it was sort of a smaller team. They kind of knew what they were doing, and they didn't really see a need to have these business domains and split up, and they were perfectly happy with that. So it's not always the case that microservices is always the answer.
Yeah, but I mean, if there's a shiny new toy and it's technology, we have to go that way.
Yeah, absolutely.
There's always resume-driven development.
Yes.
So what does serverless add to this?
So
go ahead, Daniel.
Yeah, sure. So serverless is more like a deployment model. So the microservice is some kind of architecture, how to build application, how to run independently. And the serverless is kind of deployment model, which means regardless of any application runtime, it makes you have application just run and scale down to zero without network traffic. So for example, the Monolithic application or some microservice application running all the time, like a 24/7, regardless of the container or like a virtual machine, even bare metal. But in the end, a lot of enterprise companies figured it out. Oh, our business application don't need to run all the time. And then we also need to reduce our cost to run and maintain the application. In order to solve the kind of business challenges and technical problem, the serverless actually enable developers as well as like enterprise companies solve that kind of problem. That's why the serverless, we already talk about serverless platform like Amazon Lambda or Google Function or Azure Function. It's all kind of a deployment model. So when you deploy application as a serverless, it should be running. It shouldn't be running all the time. It should be run very certain period of time, and then it will be hibernate like a scaled down to zero, like a 30 second or 5 minute. It's not development stuff. It's more like a deployment model. That's the fundamental concept of a serverless. You can bring your Microservice application as a serverless as well. Go ahead, James.
I just wanted to add that when the application is quote unquote running and not scaled to zero, it's also tracking and responding to load, so that it can scale up to multiple instances to handle additional load. This is the idea that you want your compute resource to track the load on it instead of running all the time, as Daniel said, but more importantly, tracking that load so that you can really optimize your compute usage and your networking usage, saving money and hopefully also reducing CO2 emissions and things like that.
Yeah, that's a really good point. So that's really I want to really talk about. So a lot of enterprise companies really care about like a climate change, like the carbon dioxide reducing. And then, for example, Google Cloud, they currently CO2 neutral cloud platform, and they are aiming for CO2 free by 2030. And the serverless actually allows the enterprise company to reduce CO2 based on the optimizing compute resources in the end.
So those are good. So environmental concerns, we've got operations concerns and that sort of thing. What's the benefit of serverless for developers?
So for developers, We often present this, or actually we started to present this
Yeah.
slide years ago, showing the evolution of software, right? We have the monolith on the left, and then as we move to the right, we go from monolith to mini services to microservices to serverless, and it's like this architectural progression. And the benefit to developers for serverless is they like, I mean, the naive way to say it is they no longer have to care about the server, but more importantly, they no longer have to care about the application infrastructure needed to run their business logic, because that's ultimately what you want your developers to be focusing on, is adding value to the organization, whether that's for money or for others, for other things. But you don't want them worrying about how those applications going to be deployed and what server APIs they have to call to get this one function done or this one task done. You want them to be able to write the logic for their service, and be done with it, and not have to worry about how to package it up and run it on like a traditional application server like a Java EE app server. That's really the benefit.
Well, and similar to kind of the whole Kubernetes idea, right, is that you're just kind of separation of concerns. We actually had somebody remark in the chat, right? Basically the difference is that while there is still a server there, the operational control for the server is managed by somebody other than the person who's trying to run the functionality, and that's really what we mean by serverless. But it's actually kind of the joy of containerization as well, and arguably also even the goal of a virtual machine is just that the separation isn't good enough, right? So as we get further and further away from it, what we're trying to do is just separate those concerns across different responsibilities, so that we can kind of have an expertise in running an operational and an expertise in building and running software that are not necessarily the same people, but also can operate independently.
Yeah, that's right.
So I mean, theoretically, so we've got, serverless and that sort of thing. Now, theoretically, could you have a serverless function in, say, Quarkus and Spring call a serverless function written in another language?
Sure.
Yeah, absolutely.
So it gave us, service-oriented architecture gave us that, 2 decades ago. The concept, that abstraction, right? It's like the service adheres to its contract regardless of what language it's written in, and serverless is no different in that regard. Now there's certain languages and frameworks that early on had a kind of a head start on Java in particular, and I'm thinking of things like NodeJS and Golang, and Python, and languages that were a lot more, shall we say, dynamic, and easier to kind of write and get running really fast. With JavaScript, right? It's like you write a couple lines of JavaScript and maybe you get the types right, maybe you don't, but it's still going to run. So like platforms like Amazon Lambda had kind of first class support for Node and JavaScript for running serverless workloads. Java came along a bit later, but some of the historical architectural decisions and trade-offs made by the Java platform early on, built for big iron, built for who cares how long it takes to start up, who cares how much memory it takes as long as it can maximize its throughput. Those kinds of trade-offs made it a lot less friendly to use in a serverless infrastructure environment like AWS Lambda or Knative on Kubernetes. So Node.js had a bit of an advantage there, but like I said, you can write them in any language that the platform supports.
Well, and as much hate as J2E has gotten, kind of over the years, right? I mean, at the end of the day, that whole that EE part really was service contracts, right? Maybe not called that, but that was really what was going on. So you were doing service contracts between the various components. So in some ways, in Java, I hate to reuse the word, but the orientation around being service model, right, was early on in Java, and did a really nice job of it. It was just that it required it much like soap with SOA, right? And there you go, I did it for you. What you would do, like the overhead to describe a service was so high that people kind of reacted poorly to it. But so now we're kind of getting to maybe a happy medium where you can describe a service and implement that service in like a lot of the same code, for lack of a better term. And Node.js brings a lot of that to the table. Python in particular also brings a lot of that to the table, which is super nice. So we did actually have a question from the audience, which was, so if you're a developer, right, or you're somebody who's leading developers, should you be preparing your developers to continue to work in monoliths or thinking about serverless as, what do you send them to training for, right? Not that there's a lot of training these days for monolith, but, do your developers need to know all of those deployment models, or is one better to focus on? Let's say, Daniel, in your opinion.
Yeah. So developer perspective. So I would say, so here's the thing. So yeah, of course, the Quarkus provide a lot of stuff, like not just a serverless, but also just imperative application. But general developer perspective, they don't need to actually prepare or training or kind of application skill or technology based on serverless, because the serverless is a very specific use cases. So you don't need to change your old existing microservice application or even monolithic application to serverless. So for example, James already mentioned earlier, so your application sometimes scale down to 0 or very optimized for compute resources, specifically Kubernetes or cloud environment. In that case, serverless is a really good solution to overcome the challenges. But some application, my application should be running all the time, and then the application pretty stable, and then not shouldn't be containerized or even not shouldn't be modernized. In that case, you don't need to change your application architecture or like a little bit no need to consider about the serverless as well. But so any enterprise company always think about, okay, so some specification like a business requirement that we needed to evolve existing application to serverless at any time soon. In that case, maybe you need to think about, so current runtime environment or the application framework should be changed to serverless quickly, or maybe we need to rewrite existing application, all kind of stuff. So this is just some kind of challenge for developers, even Java developer or Node.js developer or like a Golang developer, even application architects.
Imagine I'm a CS student though, looking at graduation and getting on the job market.
Yeah.
Right. What should I be learning first? What should I be assuming that if I develop a greenfield application from scratch, right, or I'm working for a startup where I'm writing all new code, what should be my sort of default pattern?
Actually, I got some very similar question in a developer conference, specifically the college student. They're really looking forward to what is the most popular and the valuable, like a program language for the seeking new job. And then they said like a Python or like a PHP for like a data scientist, something like that. And then if I were to say Java, and then they say, oh, this is kind of old stuff, like a so we all almost the same age. We really talk about COBOLs, and then it's maybe 20 years ago, old school style. And actually, the college student, they say Java is maybe 30 years ago, like some old school thing. But I want to say, so whatever they choose the application or Java like a program language, that program language could be flexible and then dynamically change for the adopting new environment, not just cloud, but also maybe coming IoT edge or like a machine learning or artificial intelligence. And then if they needed to restart or start over running new application runtime or like a programming skill, that'll be good. That'll be not good experience. So whatever they choose at the program language, that program language should be keep evolving, as well as the huge community, and then also super flexible. Any runtime, any cloud platform they don't know to use.
James, do you want to add to that? What's your
So if I was graduating today, number one, I would probably learn like the top 3 languages based on usage today, which in my opinion, I believe would be
So
Python, Java.
just to interrupt, the question was not about languages. The question was whether students should be learning microservices versus monolith patterns, etc.
Right. Absolutely, you're 100% right. And the reason, so like you said, it's not about languages. It's important to know a few languages, but they all are they have similar constructs and similar ideas, because computer programming is computer programming, for loops and so forth. More importantly, the architectural patterns, I think that it's important to learn the value proposition, or it's important to learn the main tenets of each of all of the major kind of buckets of architecture, like monolith versus microservices versus serverless. Those aren't the only 3, but I think that it's good to have a grounding in several of them, because at the end of the day, there's going to be a different right answer for each of the problem that you face, post graduation. And so if all you know is one, then you're going to try and apply that everywhere, and that's not always going to work out the best. So I don't think there's any one. I think there's a lot of attention right now on things like microservices and serverless, but the value proposition of microservices is it's pretty compelling, but it's not always, like I said, the right answer. And it's just a special case of distributed computing, which we've had for a number of years. So if you're looking at a high performance, like CPU intensive application, microservices probably not the right way to go. If you're building a highly a high transaction or high concurrency need web-based application, then microservices is probably going to be a better way to go. But knowing both is better than knowing one.
And just to kind of add to that, like in a sense, I would actually lean a little bit towards serverless because it's more complex. And so as a result, if you understand how to do like a serverless architecture pretty well, backing into like a monolithic architecture is should in theory be simpler because you already understand, as well as the fact that if you do really, I would actually say, a service-oriented architecture, whether it's microservices or serverless or, even some of the old school stuff. If you're designing even your monolith in that kind of scenario, even if you're doing your services in RAM, rather than kind of across a network, you'll actually end up, generally speaking, with a better monolithic app than you would if you weren't using kind of a service-oriented model in the design of that application. And in the future, your monolith has the kind of like split points that you could break it up into kind of a set of services or as that change happens. So that's but I would just kind of like add that little bit is that I think you bring up a really good point is that the challenge that a lot of people I think are having right now is that they don't actually understand that there are all these architecture types and they are all different and they all have different use cases, and not everything that looks like a nail needs to be hit with a hammer.
Can I actually get off into language theory here?
Sure.
A little bit?
Sure.
Well, just because Java, right? When you're building a monolithic application in Java is much more object-oriented in its design, right?
Yeah.
I mean, people who work on more recent languages will quibble with that, but that is the basic theory of design for Java. But then when you move into serverless, or at least either event-driven applications or function as a service, right, which are 2 sort of halves of serverless, you're actually kind of a necessity forced to adopt a more functional programming approach. At least I think so. I have not written serverless stuff in Java. My serverless stuff has been in other languages. So it feels like you actually kind of have to change your programming style, right, and how you compose. how you
Yeah.
compose units of work between
Yep.
serverless and monolithic
Yeah, and
composure.
I think you're starting to touch on event-driven architectures, where it's like, okay, you have these set of serverless functions that you can call, but how do you call them? Like, do you call it and wait for a response, or do you call it and set up a callback so that when the response comes in, you can respond to it, right? That's the whole concept of event-driven architectures and event stacks, and frameworks like Vertex and Play, and there's a few others that that kind of adopt that mentality. That it's almost like service oriented event driven architecture. SOEV, SOEVA. So yeah, you're right. You kind of have to change your mindset a bit if you're going to adopt serverless. Chances are you're doing so because you want to build a highly efficient and performant application that's also tolerant to failures and outages and things like that. So the concept of this event-driven architecture comes into play because it gives you things like this we call temporal temporal. I can't remember the word. It's basically the call that you make. Eventually is going to either succeed or fail in a good way, so that you can respond accordingly. It also doesn't matter where these other services are running. So yeah, I think you definitely have to change your mindset when you're thinking about serverless driven or serverless centric architecture patterns.
Speaking as a old school COM developer, so Windows COM developer from many years ago, which was an actual event-driven architecture. I totally miss it. I think there's actually a lot of opportunity in a monolithic architecture, serverless, microservice. There's a lot of opportunity for event-driven architecture. So I think they're a little bit orthogonal to kind of it's a lot actually easier to do them with a service model.
Yeah.
But they're so much more scalable. They're so much easier to identify. One of the problems with microservices and serverless architectures is that it's very hard to debug them, right? And so as a result, I think one of the things that the event-driven architecture brings to the table, right, is that it localizes where the functionality is happening, so it makes it also easier to debug. So I think at the end of the day, right, the question from the audience, right, is like. I think we're concluding that we need to find the right architecture for the individual solution, but that there's principles from kind of both microservices, serverless, even event-driven architectures that are probably applicable in all those scenarios, and we should really be considering them as well.
Yeah, and one thing to close that chapter on is that as we start to move into event-driven serverless things, like you said, debugging gets hard, right? Stack traces no longer look like the stack traces of old, where you can kind of see from from the beginning of the thread all the way through all the calls that ended up in failure. Now you get this super short stack trace that said something failed, but you have no idea why and what caused that to fail. And that's where things like observability really become way more important in a non-monolithic world. So like things like OpenTelemetry, which recently enjoyed their first release, is becoming very, very much more important, even in a serverless context, because even in the serverless context, right, a service lives for a few milliseconds, and if there's a problem in there and you're unable to observe that problem, you're never going to be able to fix it. So observability, super important, and that's one of the other things that I think any college student, when they're learning this modular distributed patterns that they're going to be using, observability has to go along with that.
And there's one thing I want to add. One thing I want to share something. So the event-driven auto-scaling, specifically like a Kubernetes, and the Kubernetes basically using like a HPA horizontal pod auto-scaler based on CPU and memory realization. It's really good to enable your workload auto-scaling depends on the resource realization. The problem is when you build on like an event-driven application and architecture on Kubernetes, it should be auto-scale based on event-driven metric rather than CPU and memory. It takes a long time to figure it out. Okay, my application like a pod scale out based on CPU memory realization. It's a really latency problem. So that's why you have some kind of new auto-scale infrastructure based on event metric, like a cloud events or a Prometheus metrics or like a AWS monitoring or even Kafka topics. So this is one of the reasons why the KDA, the Kubernetes event-driven auto-scaling, the one of the CNCF project, which is super popular, which allows you auto-scale your application, like a serverless application, specifically event-driven message rather than like a long processing CPU memory utilization.
Yeah, that's a really good point. I mean, I think that's, one of the things that we're seeing with, kind of environments like Kubernetes, right, is that we were talking before, right, about separation of operational things versus like, business logic things. Increasingly, we're moving more and more of the operational things into automatic engines, right? So, what I don't know if this is actually like a quote from anything really to like site reliability engineering, but it's the way I think of it, like I explain it, is like, you want to fix the recipe, not the cake, so, just putting new frosting on the cake, you can fix this individual cake and, and make it all better. But really what you want to do is fix the recipe. And the more we can do things like auto scaling, for example, especially when we can scale to zero, the more we can, fix the recipe so that we can put these applications in, some environment that will deal with the operational stuff around it, and then kind of just monitor that it's working okay. One thing I also wanted to bring up there, said James, I think that was a good point you were making, which is that, how do you all feel about the kind of future of the observability stuff in Kubernetes? Is that something that people should be paying attention to? Is it an important focus? Is it just something people are doing on the side because they like cool graphs? I think it's ridiculously important in a service model, whether that's serverless or not. And so I just kind of wanted to get some more opinions on that observability and tracing and that kind of stuff.
And also which tools people should currently be watching or projects.
OpenTelemetry.
I mean, that's one. That's the one that is very. Yeah. It's very much on the forefront, at least on the Red Hat side of things, in terms of being able to observe, because it has sort of that quote unquote native ability for Java applications to use it, and it's being integrated in a number of different frameworks, like things like Quarkus. I know the microprofile specifications, which we can talk about specs later, but they also have a number of observability capabilities in that specification feature set, which is fantastic. I think that is sort of, it shows you that observability is important and becoming more increasingly so as we move into this more distributed environment. So the OpenTelemetry is a good one to follow. The projects for doing distributed tracing, things like Jaeger, have been around for forever, and we have lots of products at Red Hat support and use, and you can use Jaeger to do that distributed tracing. I think the concepts are more important to learn and understand first before you can pick a particular tool set. But yeah, those are just a couple that either are up and coming or have been there for a while now.
Forever being relative, of course.
Right. Well, forever in the cloud computing, 5 years is forever. Yeah. Absolutely.
Yeah. I actually I don't know when exactly Jaeger started, but it's not 30 years. I'll tell you right now. So that's. Like I said, that's a really important space to me. Maybe I just write too many bugs, but I think being able to understand what's actually happening, kind of through your architecture, particularly when you talk about things like Quarkus and NodeJS and everything else, is that when you're having you're providing a particular piece of functionality through a whole mess of services that may be written in multiple languages, it can be really, really helpful to get an idea of what's happening kind of across that spectrum without having to know the code inside and out for 6 different languages and different communication models and everything else. So Josh, did you have a question you wanted to follow up on? Or
well, there was some of this. So one of the other person, right, is we've got observability on the one hand. Another thing is, particularly because we're talking about potentially multi-language programming via serverless, and that makes the interfaces super important. Are there any emerging standards in this area? Is there anything we should be paying attention to there?
Yeah, let me try to answer that. So you know what? So everybody has different serverless platform like Amazon Lambda, Google, and Azure, and a lot of stuff. And then the one interesting part from CNCF, the serverless working group try to standardize the serverless, like not just platform, it's more like a processing model. So for example, they try to give us some specification in how to define like a serverless function requirement and life cycle and invocation type, and then like a fast controller and event sources, how to handle that. And whatever you implement or stand up your serverless platform or serverless runtime, you should fulfill this mandatory requirement for the standard serverless platform. And then you know, so many enterprise company looking forward to like go to adopt like a multi-cloud or like a hybrid cloud strategy, which means your application could be or should be running on Amazon Lambda as well as Azure Function or Google Cloud anytime soon. So in order to do that, we definitely need to standard serverless like a model or architecture rather than tied into specific cloud provider. So that's the reason why CNCF working group actually working on that. And then we don't have any, okay, Amazon Lambda is in the standard, but we're not going to say that in the open source community and the ecosystem. But we can say, okay, this is a standard serverless processing model with the some mandatory architectural characteristics and the features.
Yeah, one thing I'd like to add to the interface or the interface question is like when microservices started to become really popular, however many years ago, 7 or 8. The other thing that became really popular was like using HTTP and REST, and no one really got the REST thing. Like they call it REST, but it was really just one simple interface that there was no actual URLs and URIs and ability to address objects. You just happen to create this quote unquote HTTP GET interface and you called it REST. But in many cases, it was using HTTP, completely type unsafe. Like it was super easy to make bad HTTP calls. And so I think what we've seen recently is a resurgence of the old days of RPC with things like gRPC, where you get a lot more stability around these interface contracts that we're so heavily dependent on in a serverless and in a event-driven and in a microservices world. So I think those more advanced interface definition types like gRPC and JSON, and there's several others. Those are good to know and not just rely on, okay, I know HTTP and I should be good.
Yeah, that's a really good point. And then also to including the cloud, event-driven application with this serverless, so maybe cloud event, maybe you might heard about that before, because the cloud event provide like a standard event-driven, messaging format. So for example, you have a React application based on multiple language platform. Okay, I want to use a JSON format, like a RESTful API, or I want to use XML or binary or a protobuf. It depends on what kind of application you're going to do that. But the problem is for the serverless platform or serverless application, maybe you have to interface with a different like a event-driven messaging format, which is totally like a hassle, not easy. So, and the cloud event actually solve that problem. Okay, whatever you take the application language or Go, JavaScript, or Java, Python, the cloud event, the standard format, you can easily communicate the event-driven architecture with the serverless application.
Yeah, I thought it was kind of funny. We were talking about kind of event-driven architecture, and we're kind of giving some examples of those implementations. And I think people don't really realize this because very few people use it this way. But Node.js actually is intrinsically an event-driven architecture. Like that's exactly what it's supposed to do. But because event-driven architectures are so complex, right, that people find them so difficult to use, they slapped a plugin on top of it called Express and made it into a website, which is like the opposite of what Node.js is supposed to be for. So I think it's kind of interesting. We see a lot of Node.js implementations that are literally doing like the opposite of its kind of original event-driven architecture goal. So, Josh, did you have another question you wanted to ask?
I do, but why don't you go ahead?
So I was going to kind of move on a little bit. Like, where do you feel like the advantage of looking at these architectures and thinking about, whether we're talking about something like Quarkus or serverless or whatever, where is the advantage of open source in those models? Like, why is open source a better solution to that problem?
Is there a non-open source solution?
Probably. Lambda.
Like you mean the Amazon Lambda?
Yeah, that's a good example. That's a good point. Yeah, so I mean, obviously the value, I keep saying value proposition. The benefit of open source clearly is that you get more eyes on it. It gets it's more secure. It's more fun to be a committer on a project or to feel like you're giving back. So those are all good things. I think that open source won a long time ago, in my opinion. And so even though we have things like AWS Lambda, I think that in the long run, open source will continue to win. There are other frameworks like things like Knative that run on top of open source platforms like Kubernetes that will, at the end of the day, I think, become more widely adopted as Lambda is sort of a stepping stone to a number of other AWS services, none of which are open source. I think that has diminishing returns to organizations that are looking to standardize their practices in terms of hiring and training and purchasing of supporting products. I think that's going to be decreasingly a value proposition to a company or to an organization because things like vendor lock-in and other concepts that are not really technical in nature, but more I don't know what the right word is, but non-technical considerations. I think open source is a better thing for companies to adopt. But that's just my opinion.
Yeah, I strongly agree with that. So just one thing I want to share, like open source value proposition. I mean, not just serverless, all kind of like a technology ecosystem. It's so flexible, and then whenever you are looking for the a next feature or more flexible things happening, you don't need to wait for the next release, like it's like a vendor product. So you just pull request, and then you can contribute it directly, and then there are so many like individual contributor, but also like a user group or even vendors, trying to make it better, make it more flexible, not tied into specific product or specific technology. So serverless, of course, is to keep evolving super fast, just not like a monolith. It's really fast, like a IoT, Edge, AI, ML. So anytime soon, what happened, who knows? And then the open source community, so flexible, adopted that kind of fast change rather than like a more like a vendor life cycle, like a product thing. So that is one of the value proposition. I mean, open source community and open source project to keep chasing fast changing the new technology.
Yeah, if you're going all in on serverless for your organization, do you really want to have that dependency long term? Or do you want a platform that you can not only understand yourself, but also find other folks who have either contributed or also are in that community to help out when you need something? It just seems like a better value proposition. If you're just doing a one-off thing, then yeah, maybe it'll work and work for you. But longer term, a big bet made by an organization is better to be bet on an open source project. Because I mean, also the business continuity concern, right? If that vendor suddenly goes out of business, maybe AWS might not do that overnight, but having those dependencies on open source means that you can continue to run yourself if needed.
Yeah, I mean, it's not all roses and I don't know
Yeah.
but
Yeah.
I mean, we have open source projects fail as well.
Yeah.
And that happens. But at least at the at the end of the day, it's actually like really really old school software acquisition, right? Where as part of your software acquisition, you would actually get what do you call it? But basically, they would give you a copy of the source code, but you couldn't actually see it. It was like in a safe held by a lawyer.
Escrow.
Escrow. That's it. And so that sounds good in theory. It sounds comparable in theory, except that it's not, because you have no idea what that code looks like. You have no idea how it works, et cetera, et cetera. But so it, like I said, it's not perfect, but it certainly, I think, gives a certain modicum of, defense against, vendor lock and vendor negativity, right?
Right.
Which is also huge. But the other part I think is really interesting about the open source with a lot of these models or these architectures, whatever, is that the innovation is there in the sense that, like, if I can just go off and like build the next chunk of Knative or whatever, I can say, hey, this is what I think should happen with serverless, and that's a huge advantage because, like, even if I'm wrong, right, at least an idea has been tried, right, that people have rejected. Or if I'm right, there's no barrier, right, aside from my technical ability to just saying, hey, I think we should do this events this way or whatever. So I think there's a lot of huge advantages. I think we're all a little biased on the show, but
right. That's where the innovation is happening. I mean, there's so much happening in open source.
Right.
Yep.
Yeah.
That's what I would want to bet on if I was making a big bet.
So, any final thoughts on the future of serverless and Java programming and microservices and everything else?
The future's bright. I think that additional or like further advancements in the serverless space, including ultimately standardization, is going to be an important and ultimate. And I think it's inevitable that we will get to some level of more standards in the space. I think that the advancements in Java, things like Project Loom, which is going to make that the whole event-driven callback kind of thing a little bit easier. Projects like Quarkus that we mentioned a few times, which is kind of really focusing on the optimization of not only the JVM, but also on the frameworks that ride on top of that. Those are really important advancements in the space, and I think those will continue to thrive together and really, hopefully, in my opinion, make Java sort of bring it back from the dead that it's been dead for the last 20 years, but really make it a first-class citizen, both in terms of Kubernetes native Java, as well as serverless applications, and get rid of the old, the outdated idea that Java's big and slow.
Yeah, and then one thing I want to share, the future of the serverless space. I think the serverless can be integrated any like a workload, not just a web application, but also you can integrate serverless with the service mesh or AML or any kind of the use cases and workload pretty easily. And the one good thing for the developers, maybe they need to choose the right program language or runtime environment to make them easily enable the kind of integration on the just out-of-the-box feature rather than I need to add some kind of third-party library or some of the complex configuration. Yeah, so that is one thing. So many integration will be happening for the serverless and then a lot of enterprise use cases and workloads.
Yeah, I think a lot of people don't really think about the fact that, like a bus architecture, internally to the big iron enterprise corporation, right? In a lot of ways is an event-driven architecture, if not entirely, and that serverless solutions can be a great answer for those. And in fact, like, when back in the day when I build like trading apps, like stock trading apps, it's kind of like you look back on it and you're like, oh, that actually was kind of like a serverless application. That was event driven, and it was fire and forget, and that was how the system worked because it was the only way it could scale successfully to the to the workload. And so there's a ton of examples out there where microservices certainly, but I think serverless is really a good solution. And as serverless gets stronger or gets more sophisticated, I think that we'll see even more opportunities for why designing your application around a serverless architecture might work for 60, 70, even 90% of your application, which I think is a really interesting movement forward. So Josh, I see we had a question from the audience. Did you want to add to that or bring that up?
No, this is when one person online had some questions about scaling, which we'll get into HBA and the like. Which would be, it'd be very interesting, except we're kind of at the end of the show time. So let's follow up on Twitch except we're going to lose the restream. Is there a place where Dwayne can go to ask follow-up questions? Is there a good place, a community place for it?
Now there is a community, not community, like a forum page on the Kubernetes by example. So go to kubebyexample.com and then go to community help essentially, and the feedback or whatever, and you can community hub, and you can go and if you like continue the conversation there, and you have people who are wandering around in there, and
you couldn't even know our Twitter ID. I can answer that. Any auto scaling question.
Yeah, exactly. So Dwayne or anybody else who's watching the show, check out keepbyexample.com and let us know your thoughts.
Yeah, hold on. Let me find a link to the forum before we log off.
I actually have it. If you need one
okay.
second.
Yeah, I do not have it. So if you want to paste in a link to the forum, there we are.
Yeah, I had it, and then I managed to, when switching windows, click on a different page.
Okay.
Just to be easier.
Okay, hold on just a second. I'll paste it into chat before we log off. There we are. Okay. And
now we both do.
Yep.
All right. So thanks so much to our guests. Really appreciate it. Again, I apologize for my location. I'm at a conference, and I thought it would be kind of cool to do something in kind of a public place, but apparently my mic is not doing as well as my old Apache helicopter mic, where I used to be able to do a meeting from anywhere. But thanks again, Daniel and James, and we hope we will see you around on the interwebs.
All right, thanks for having us.
Thank you so much for having us. Have a good rest
Thanks,
of the day.
everybody.
Bye-bye.
Bye-bye.